All right, guys, so these two work out really similar to how the two on the first review go. Anytime you're trying to find all the roots, right? First thing you want to do is put it in a calculator, because that'll give you some at least real roots where it crosses the x-axis, and maybe it'll give you some integer roots that you can use for like synthetic division. All right. So if we graph this one, you kind of get this picture at the x-axis, right? And this one's nice. On Desmos, you get all four solutions, all four roots. Because remember, we're looking for 4. We need to find as many as the degree is. So in this case, we got all of them from the calculator, or from Desmos, which is nice. We got -8, 0, 4, and then -0.4. No decimals. So you got -8. 0.4, think about what like 0.1 is. 0.1 is a tenth, right? So this is 4/10 or 2/5 is what it would be. So that would be -2/5, and then we got 0, and then we got 4. All right, so those are the 4 solutions, all in Desmos. So that was easy. The next one isn't as nice, but it's not too terrible. So you're looking for 3 zeros. You have to find 3 solutions. Now they may not all be real. It may not cross the x-axis that many times. It may have some imaginary roots or irrational roots where it gives you like that really long decimal that won't turn into a fraction. So what you do is you want to put this in still and kind of see what you can get. We need to find 3 solutions, because there's 3, because the degree is 3. And when you put that one in Desmos, you see this, like you see these 3 x-intercepts. These you can't do anything with, but here this 6 can get us started, right? That's a good, because you always want to find at least one good root. That one we got a 6 to work with. So I'm going to use synthetic division in this 6. Now, note I didn't change the sign, because you only change the sign if what you're dividing in is like coming from a factor. So if we had like, you know, this divided by x minus 7 or something, like if we did this, like divided by x minus 7, then we would do the opposite of 7 and put, or -7 and put +7 here. Or if this was like divided by x minus 6, then we would use +6. But when you're getting the value straight from the calculator or the graph, it is what it is. You're not changing the signs. So this is the only one we got to work with here. So we're just going to use synthetic division. And we want to take it from a cubic down to a quadratic. So we're dividing out this one that we know. I'm going to bring it down. 1 times 6 is 6. Add these, we get 9. 6 times 9 is 54. And then 49, -49 and 54 is 5. 6 times 5 is 30. And we get a 0 remainder. We have to. We know 6 is a root. If this is a root, you don't have a remainder. You have a remainder of 0. If you get anything other than 0 using synthetic division with a number you know to be a solution, something's off in your math, all right? So double check it. But now we're down to this, which is what we needed. If we can turn any polynomial into a quadratic by, like in this case, we divided out a 0, brought it from an x cubed, and now it's down to an x squared when we divided this out. Now we can use quadratic formula, or like some other ones where there's like a number, a 0, and a number. Those I was using like the square root method, like solve by square root. But here, we can't use that. We just have to use the quadratic formula. So we get -b plus or minus, and then under here you have b squared minus 4ac all over 2a. And like I've said a few times, I always find the discriminant first, which is this value under the radical. So, sorry, I meant to write ABC here. So, A is 1, B is 9, C is 5. So I'm going to figure out this value first. So B squared, 9 squared, minus 4 times, AC is 1 times 5, so that's 5. So we got 81 minus 20 equals 61. So that's my value that's going to go under the radical here. So I'm going to rewrite this now. I'm going to put B in for the negative. So I'm going to say negative B, so that would be minus 9. Or opposite B, like if this had been a minus, this would be a plus. Plus or minus square root 61 all over 2a, which is just going to be 2. That's my answer. Those are my next two roots. Like if you were to put this into the calculator, what it equals is these two values that we found here earlier. But this is an exact version, like this is an exact value, not rounded or anything. It looks it looks confusing just the way it's set up, like negative 9 plus radical 61 over 2, or negative 9 minus radical 61 over 2. But those are your last two solutions. So you can just write them together. You could just leave them as like a plus minus here, like negative 9 plus minus square root 61 over 2. And those are your three answers, your three solutions. Like we have negative 9 plus square root 61 over 2, negative 9 minus square root 61 over 2. Okay? So those are our three solutions. The other problem on the review works similar. I think it's like 7. 7 comes out of it, whatever the polynomial is, and you end up having to use the quadratic formula again. Right? So that is page 2. I'll do another one with page 3 here in a second.